Hello, welcome to the video on 7.2, which is one sample proportion confidence intervals. Okay, so what happens here is we're sampling from a population, and we're interested in obtaining the population proportion, or sometimes we could say the population percent, the percent of the population that may lean one way or another way. Okay, we're trying to capture this. That's how we like saying this. We like to capture P. Okay, with confidence. Okay, so I have to show you the idea. Of course, you're going to be using Statcrunch most of the time, but you should have an idea of what's going on here, especially if you're going to go on in statistics. Now, what happens is if you sample out of here, okay, if we sample out of here, we're going to be getting these p hats. So these p hats. Okay, so p hat is it's called the sample proportion. So it's generally denoted as x over n. But what is x? X is the number of successes that you're interested in from the sample divided by the sample size. Okay, so it's very basic concept. If say I took a sample out of here and I asked 100 people if you're going to vote for candidate A or candidate B, and say 65 said they were going to vote for candidate A. So that means that p hat in this particular sample would be 65 over 100. Okay? Sometimes problems do it this way. You have a population, and they said out of 650 people, 40% said A. So you have to find X. You have to find X. Okay? Because when you're doing these on Statcrunch, you're going to have to know a few things. You're going to have to know what N is, which is the sample size. And you're going to have to know X, which is the number of successes. The number of successes out here. So what happens here is if they, so the formula is here. It's p hat equals x over n. So if you're looking for x, we just multiply this n across. So x is actually equal to n times p hat. This is the number of successes is actually equal to n times p hat. Okay? Alright, so let's go ahead and talk about the idea. So if you take a sample from these proportions, we're not dealing with a population anymore, we're dealing with a sampling distribution. Okay, but my statistic, these are all statistics. Okay, this represents this graph. This graph will actually be approximately normal if n times p hat is greater than or equal to 10, or if n times 1 minus p hat. It's kind of similar to the central limit theorem, okay? Or this could be considered the central limit theorem from the sampling from the population p. Okay, so if you remember, what's the average of all these p hats? The average of all these p hats, if I get the average of all these p hats, that's going to be equal to p. Okay, so the thing is we don't know this p. That's the problem. We don't know this p, but we're trying to capture it. Okay, so what we do here is we try to estimate this p with some confidence. So what that means is that if I said this was 95%, if I said this was 95%, okay, so 95% in the middle, what's the z-score that tells me, we call this a critical value, what's the z-star that tells me how far you're apart from this for a 95% confidence interval? Okay, so we learned a rule before that if it was 95%, you could go 2 standard deviations. We could go 2 standard deviations this way and 2 standard deviations this way. But if we use calculators, okay, so the z-star for a 95% is actually equal to 1.96. Okay, so we could find all these on our calculator, but it's good that you need to look at your formula sheets and know all these, or take them down from class. I gave all these in class because you need to find like the z for 90%. Okay, and sometimes they'll use this term alpha. Okay, so alpha is nothing more than 1 minus your confidence. 1 minus your confidence. Let me do this because they bring this up a lot later. I didn't talk about this in class, but it's just 1 minus your confidence interval as a percent. Okay, so if I wanted a 95%, then alpha would equal 5%. Okay, so sometimes they do that. It's the area that's outside of the inside. Okay, so if this is 95%, my alpha would be whatever's outside of that. Sometimes they ask you that. So instead of that being 90%, they'll say 5%. Or sometimes they'll say alpha divided by 2. This would be the one-tailed area. Just don't overcomplicate it. If this and that thing equals 5%, what's just this alone? That's 5% divided by 2. 2.5%. Okay? So if you're at 90%, okay, so that means your one-tailed probability is 5%, right? So if you're at 90%, if 90's in the middle, what's over here? Well, if 90's in the middle, this must be 5, and this must be 5. So my Z 5% would be 1.645. That's if I was asking for a 90% confidence interval. But anyways, let's get back to this thing. I'm going to draw this picture again. Get back to the idea. Okay? So if I was P and I asked for a 95% confidence interval. So that's how many Z scores away am I? That's your critical values. So what happens here is, let's say I reached into the sample and I got a p hat over here. Remember, this is 95%. Okay? So if you think about it, you can say, well, how often is these p hats going to fall in here next to this p? So if a p hat came right here, so just imagine, this is my p hat. And this is unknown. This is unknown. So this is my p hat and it fell right here. So I'm going to draw the same thing down here. Now what happens here is, do you see how this here, from the distance from here to this middle? Okay, that would be this would be 1.9 standard deviations this way. This one will be this way. So what I want to do is I want to take this distance right here. Let me color code it. Take this distance from here all the way to here, and I want to add that here. So I'm going to go all the way over here. I'm going to take this p hat and I'm going to subtract that. Did we catch p? Did we capture it? Yes, we did. So what this means, this would be one sample. So let's say I took 100 samples, so I have 100 p hats. So you keep getting these p hats. 95% of the p hats, okay, will capture p. For 95% of your confidence intervals will capture p. Because here's would be another example. I'll give you an example where it doesn't. Let's see my p hat fell over here, because that could happen. If I did a 95%, it's going to land outside. It's going to land over here and over here, is it for a total of 5% of the time. So this p hat right here would be here. So if I add 2 standard deviations this way and 2 standard deviations this way, see, I missed p. P's over here. Wasn't in my interval. An interval looks like this. There's a start and there's an end. And we hope to capture the real p from our population. Okay? So out of 100 confidence intervals, we'll capture p, we'll capture the true p, the true parameter, about 95 times. Okay? Now this is the idea. Okay, you guys are just going to be plugging into Statcrunch, but you should have that idea. When you get done, you should have the idea of how confident are that percentage is in there, that p is in there from the population. Okay, so let me pull up a homework and just show you how easy these problems are. Okay, so let's go to 1. Let's go to a new page. Okay, so they say here that 43% of this many people. So whenever you're given that 43% is the best estimate, I never gave you the formula on the last page. Okay, so this is the formula for a one proportion. So if you want to try these by hand, you could do these. Remember, proportions will always be z's. This is actually the sampling error for all your p hats. Remember we did it for x bars? Oh, I lost it. Did I lose all that stuff? This is actually normal. The average of all your p hats will be p, and the sampling error is p hat 1 minus p hat over n. Okay. So what we want to do here is the formula. The formula, you're going to get the estimate. This is from your sample. You want to add and subtract. This comes from your confidence interval times p hat 1 minus p hat over n. See, I don't know p. I don't know p. If I knew p, that would be a p right there. But anyways, so these are the things you need to know. You need to know what your sample size was. You know how many successes there were out of that. Okay? And you have to know the confidence. Okay, so 43% of that many people, 21,944, answered yes to a given question. Given that 43 is the best percentage, why would we need a confidence interval? Okay, so you guys could just answer that on your own. I'll do one of those in a sec. Let's do this one. Okay, in a week before and after a holiday, there were 13. So my n, this is how many total people there were, or how many deaths there were. This many occurred before the holiday. Constructed 90%, which is equal to 0.9. Okay, so now we just go to Statcrunch. Now listen, if you were going to do this by hand, you would do this like this. So your estimate, your p hat would be 6435. If you wanted to try this out, just to get your knowledge a little better, you would add and subtract. 90% is 1.645. Okay, so this is going to be a big square root. What you do is you put this in your calculator. So let's see if this comes out to be something small or something big. 6435 divided by 13. Okay, good. So this is going to be 0.495 times 1 minus that, which will be 0.505. If you do 1 minus this number, that's what you'll get, divided by 13,000. Just give me a second to get rid of this. Okay, so if you wanted to do this all by hand, you could do all that by hand. Okay, so what we want to do is we want to Statcrunch, so make it a little easier on ourselves. Okay, so let's go and hopefully this comes up quick. So I'm going to go Stat. I'm going to go to Proportions, one sample, Summary. We don't have data. If they gave us data, it would be a bunch of yeses and nos. Okay, the number of successes, that's 6435, that's X. Number of observations is my sample size. How many did I sample? Okay, now go to Next. Don't hit Calculate, go to Next. We're not doing null hypothesis yet. And I want to change this 0.995 to a 0.9. Now calculate. Now, just throw these numbers in here, okay? And make sure, yeah, that won't go away. So they want us to round to 3. So this is your lower limit, so it's 0.488. 0.488. And the upper is going to be 0.502. Oops. 0.502. Okay. That's it. Now they always ask these questions. Does it appear to post? Okay, so if you look at this, these make sense. So if the argument's 4 in there, okay, see, this doesn't make sense. Yes, because the portion could not easily equal 0.5. Well, since 0.5 is in here, that means that it could easily equal that. Since this is in there, it could equal that. Okay, so that's just the common sense that you have to do. See, this is a contradiction. Yes, because the proportion cannot equal 0.5, but 0.5 is in my interval. Anything that's your interval could easily happen. Okay, stuff that's not in your interval can happen. Doesn't easily happen. It could happen, but it's unlikely. Okay, so let's look at 7. Okay, so the main thing is you're always looking for these three things. Sometimes they give you n in the percent, and you have to multiply those two. Okay, to find x. Okay, somebody says, oh, this is the backwards problem. Okay, so let's do this backwards problem real quick. We did this in class. Okay, here's the formula. The formula is, okay, n has to be greater, not greater than equal to, greater than. Okay, it's going to be this p naught squared, which generally divided by margin of error. Let's see if this works. Over z star squared. Okay, so let's just plug these things in here. So if they don't give us a proportion, this is from your sample. Okay, generally we don't know this because we haven't done a sample yet. We're trying to find n before we sample. We're trying to find n before we sample. So see, it doesn't make sense for us to know p hat. So what we do is we just use p5. Okay, p5, because that maximizes this. 0.5 times 0.5 is 0.25. That'll maximize this numerator. Okay. Okay. Okay, within 8 percentage points of the true population mean. Within 8 percentage points. Okay? So if it's within 8, what's the margin of error? If it's, like if I said within 8, this has to be within 8%. Sorry, it says it wants to be within 8. So 8 from here to here is 8. Now remember, just one side is your error. That's what you add, and that's what you subtract. Okay? So this must be 4%, and this must be 4%. Okay? So within 8 means that your margin of error is 4%. Okay, so this is going to be 0.25. Oh, sorry, I'm sorry. Yeah, 0.25. That's 0.5 times 0.5. But let me show you the whole formula. Okay, we did this in class, so I'm kind of going fast. 0.5 squared. The margin of error says within 8. Within 8 means that the margin of error is 4%. The z, they want us to have a 90%. So 90% is going to be 1.645. That's your critical value for 90%. Okay? So n has to be greater than this number. No matter what it is, we are going to round up. Okay? Whatever this comes out to be, we're going to round up. So I know you have to just be good at this on your calculators. Okay? So the way I do it is I already know this top is 0.5. Okay? So this is how I do it. I always do it the long way. I'll say 0.04, that's this. I'll divide this by 1.645, so I just did this. Now I'm going to go ahead and enter. Now I want to square it. Now this is a very, very small number, but 0.5 times 0.5 is 0.25. Divided by, now I want to store this number. That number is stored into my answer, a second answer. So the answer should be 423. That's how many people you need to sample. So this works. Oh, something went wrong. Z squared, that's what I did. That's what I did. This is the same formula that I did. Within 8%. So maybe they want 8% here, which would be within 16%, but I'll just try. The formula I gave you is the same formula that they did. They just flipped it. They took this flip thing and they flipped that up. So let's try and see if that's what the problem was. 0.08, which it shouldn't be, because if they say within 8%, I guess that's within 8. Maybe that's the problem. Divided by 1.645. Okay, I just get everything in here and I want to square that. Now I'm going to do 0.25, because that's this times itself, divided by that. Okay, so let's see, 106. Okay, so that was the problem. So they were actually saying within 8%. So within 8% this way, and within 8% this way, which would give me a length of a total interval length of 16%. Okay? Generally, when they say within, for the most part, if I said within a certain percent is, you said, well, this is within 4. Yeah, that's within 4, within 8. So that would be 4 this way and 4% this way. But they didn't see it that way. Okay? So I'll give you the formula for this next one. See, I can just read through it real quick. See, 90%. So I know my z star equals, okay, 1.645. Okay, within 5 percentage points. So my margin of error, or my error, will equal 0.05. Okay, surveyed, paid for. What else do I need? And this will always be 0.5. You always round up. So it's going to be 0.5 squared divided by e, which is 0.05, divided by 1.645 squared. Okay. So I'll try it another way. Okay, so let's use parentheses here. 0.5 squared, that's my numerator, divided by, let's use a parentheses, 0.05 divided by 1.645, close it, and square it. Make sure I'm right, 645 mistakes. Okay, so 271. Always round up no matter what it's at. See? So just use the formula there, and that'll be it. Okay, so you should be fine. Remember, if you're always looking for n, x, and the percent. Okay? So the confidence interval percent. Now remember, they could give you n and the percent of the sample. They give you n and the percent of the sample. What you have to do is you have to find the expected. To find x, you would do n times p hat. See, that's p hat right there. Okay? That's how you get it. And then just round this. Round it normal. Your normal way. And you'll have it. And then you just use Statcrunch. Okay, so that's it. Good luck.